Hello everyone. Today we will use default data to calculate sensitivity, specificity and draw ROC curve uh, by various methods. We can try LDA, we can try QDA, and we can also try logistic regression. Okay. But as I said, for drawing an entire curve, we will need cutoffs. Okay. We will need to try various thresholds. And by default the LDA and QDA commands will give me the grouping as per 0.5 threshold. Okay, we have seen the formula for LDA, right? We have to just compare the numerator P1x, P2x. So we will compute those P1x, P2x manually here and then we'll see what happens. Okay, so let me load the library and get the data. These are the variables in my data. Okay, so for LDA, we need to have a pooled estimate of sigma. So let me call it sig pool. So that will be cove of. Okay, let me first create subsets of default data. So no default subset is subset D and default equal to no. Let me check the dimensions. Dimension of ND is 9667 cross 4. Okay. Similarly, I will create yes default YD as dimension D default equal to yes and dimension of YD is 333 cross 4. Sig pool will be covariance of ND. Of course, we don't want the default variable, so -1 into n row of ND -1. Okay, this is CSSP matrix for the first subset. Then we will do similar thing for the YD group. N row of YD -1, covariance of YD, and this whole thing divided by total number of observations, that is N row of D. This is my pooled estimate of sigma. Okay. Okay. So let me check. So we are getting an error that we have a non-numerical variable. Let me check class of $student. There is a factor variable, correct? And we know that this is a problem, but as we discussed, we will convert it to numerical. Okay. So initially itself I will do that. So here $student we will consider as dot numeric $student. Okay. Now I'll run these things again. Now I get the sigma matrix. If I print it, okay, I've got the sigma matrix. So let us now use this sigma matrix. We are trying to study performance measures. With this sigma matrix, we will calculate P1x, P2x. Okay. So I'll call it Px. Px is function of given x. I need mu1 hat, mu2 hat also. Mu1 hat is means of, if I call yes as class 1, then means of YD minus 1. This is my mu1 hat, and mu naught hat, that is no as class 0 if I consider, then mu naught hat is colmeans of nd minus 1. Okay, so px is now a function of given x. What do I have to compute? P1x is the multivariate normal probability of x having come from mean mu1 and variance covariance matrix sigma 1. So I think there is a command uh, rmvnorm in some package. Does anyone remember? Multivariate normal density. There is an MVT norm package which gives me multivariate normal density, DMV norm. Okay, so we have to give x, then mean and sigma, and we can directly get log value if I consider log equal to true, but as of now we don't need log value. So let me load the mv norm library. So library mvt norm, p1x is okay. So P1x will be prior probability into this PDF. Okay, so prior probability for default class we know. So that is, let me take pi1 as n row of default. So yd divided by n row of d. This is my pi1, and my pi naught is n row of nd divided by n row of d. Okay, pi1 and pi0. We could actually compute this outside because we are not going to change the data in between. So let me print just to confirm that the values are correct. Pi1 and pi0. Okay. So P1x is pi1 in DMV norm x comma mean equal to mu1 hat comma sigma equal to sig pool. Okay, this is p1x, and p0x will be pi naught dmv norm mean mu naught hat sigma equal to sig pool. Okay, but of course we know that there is a norming constant in the denominator. Okay, so I have to make sure that these two guys add up to 1. So I will create a vector p which I would return as c p naught x comma p1x divided by their sum. So p naught x plus p1x. and then I'll return P. Okay. Let me run this and see if it works for something one vector, and then we will go to others. So let me suppose try Px of first entry of ND, suppose Px of ND first, of course without the default variable, so -1. DMV norm, yeah, my spelling is incorrect, it has to be DMV norm. Okay, norm. Let me run the function again. See, it gave probability of P naught is the zero class probability. So zero class probability it gave as 0.99, and class 1 probability it gave as 0.003. Let me try for YD, first observation from YD. Even though the actual value is yes, it gave probability for default as 0.06 only, and probability for non-default as 0.93. Okay, so we are getting these probabilities. Now what we will do, we will try different cutoffs and get number of correctly classified observations in each class. We will compute sensitivity, specificity, and we will draw ROC curve. Okay, so what are the thresholds that I'll try? So I will create a sequence from 0, 1. So sequence 0 to 1, length equal to 1000. I'll try various values of threshold. And for each threshold, we will try classification, and then we will get true positives, false positives, and sensitivity, specificity. Okay, so how do we do that? So predicted classes we have to compute, we have to get. So let me first create a blank vector for predicted classes. In general, PCI, how would I get PCI? So I will predict for ith observation from D. Okay, so I will first compute Px. So predicted probabilities, pred probe, Px of ith row of D, of course without the first column. After these predicted probabilities, if pred probe is greater than the given threshold, then we will assign that if the first entry of pred probe is greater than threshold, then we will assign that observation to that class. So in that case, PC at I, let us use if else, because otherwise we have, or okay, another option is I create PC as zeros and I change them to 1 only under certain conditions. Okay, repeat 0 in row of D times. If pred probe 0 is the first class, so I will change only if pred probe, so I will change only if pred probe 2 is greater than threshold. If pred probe 2 is greater than threshold, then I will change that prediction to class 1. Okay, otherwise let it be. We do this for all i's. So for I in 1, 2 in row of D, we do this. Then we have to compute how many true positives are there. So just as a trial, let me take threshold equal to 0.5 just to see if the code works. Let me now print. So table of predprobe, sorry, table of PC predicted class. Okay, so 9898 are predicted as no default and 102 are predicted as default. And how do I get true positives, true negatives, etc.? So I will need table of PC versus first column of D, C. So the diagonal entries of this give me correct entries. So let me store this in T. Okay. So true positives are these 80 values, correct? So these are predicted also as yes and actually also as yes. Actual is here my column and predicted is row. So true positives are this, true negatives are this. So true positives are T22. Let us check. 80, correct. True negatives are T11. Okay. And I want sensitivity. So sensitivity is true positives divided by total positives. Total positives is total number of defaults. So n row of YD. And specificity is true negatives upon total number of negatives. So n row of ND. So let me run these two. See, as of now, specificity is 0.99 because yes, negatives are easy to detect here, and sensitivity is only 0.24. This is with threshold equal to 0.5, but we have to try various values of threshold. So let me now do that. So for, let me take NT, number of threshold as 100, and I'll write NT here. For I in 1 to NT, first I have to okay, I can't use I because I have used I here in between, so I'll make it J. For J in 1 to NT, thresh equal to threshold of J. Okay, then all these things go through. Let me just shift this a bit so that the code is more readable. Now sensitivity and specificity also have to store for every threshold. So sense J and spec J. Okay. So I'll define them as blank vectors. Sense, sense and spec. Okay. Let me try running this. It has given an error. So let me see what the problem is. See, there is a possibility of only one prediction coming out. Okay, so what to do in such case? For which threshold has this happened? For the first threshold itself. Okay, so what can I do? We could define PC as a factor. Okay, so PC as a factor and then declare its levels so that it will print 0 even if no prediction is happening for 1. Let us check the help for factor. See, we could create levels of the factor here. Okay, so let me do that. So PC I will define as factor. I will keep it 0 but levels equal to 0 comma 1. Okay, then let us see if it works. This will take time to run because every time I have to classify 10,000 observations and I have to do this 100 times. We can see the progress here. So J value can be seen here. So I tried this for 20 cutoffs only because for 100 it was taking a lot of time to run. So let us see what is the performance for the 20 cutoffs. Let me first plot sensitivity alone and then we will draw ROC. So plot of threshold versus sensitivity. See, sensitivity goes on decreasing. We can try specificity. Specificity goes on increasing. That is expected that they should move in the opposite direction. So for ROC, I have to plot 1 minus specificity on x-axis, correct? And sensitivity on y-axis. See, this is the ROC curve. This is the pattern that we expected, correct? And ideally, as I said, we want a point here. So the point closest to it is this. So that is equivalent to which threshold? That we will check. Okay, so it is, I think, so we can actually compute distance of each point from 1 and see which gives me this sensitivity. So sensitivity greater than 0.8, I can see which SENS greater than 0.8. First two. Okay, and out of them what is the specificities? So spec for first two. So specificity for first two is okay 0 and 0.88. So we want this high specificity also, right? 0.88. So threshold number 2 gives me the best value. So threshold at 2. Okay, so here cutoff of 0.05 is giving me best value for LDA. For QDA now you can do as homework. The only change you have to do is instead of using sigma pool, you have to use separate sigma hat here. Rest of the things will remain more or less the same. There won't be any change. Okay. And for logistic also try to see how we can get probabilities from the GLM code, or can we directly change the threshold in the GLM code. Okay, and if you can manage that, then try to draw ROC curve for logistic also. Okay, let me stop here for today. Thank you.